Hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back with another simulation part of MATLAB project, and you can consider it as a final year project as well as your MTech project also. So let's get started without wasting any time. So what is the consideration in this project simulation? It's we are interconnecting three different sources like solar, wind, and grid, and specifically given to the subject the specific load like household load. It's a 1.5 kilo. And at the end of this video, you can get the calculations also and what is the saving that you are getting from combining these solar and wind types of renewable sources with respect to grid. So let's start with some introduction. This all the projects, the whole the content will be covered in this video, and this is a basic problem definition because every time you are doing some new project, you need to understand why you are doing new projects, and that totally explained by the problem definition. What is the problem and how you can resolve it? Because engineers are the problem solvers. So what is the first point? Mostly electricity generated from the non-renewable sources. Non-renewable sources means coal, natural gas, oil, nuclear energy. And once these resources are used up or uh, completed, they cannot be replaced. You cannot again generate this coal. You cannot artificially generate gas or natural gas because you can generate a gas like a biogas, but it's a natural gas that we are getting from the earth, which is major problem for the humanity and currently depends on the supply. We are currently depends on the mostly on the on this energy source. On this we are currently in India. We are currently depends on these sources, and it will completed soon. Actually, we are learning this sentence, this point since our school. So when we are in the school, we are we were in the school. We were learn this topic most of time. So what is second topic? What is the second one? In the rural area, continuous of electric supply is very low. You are not getting continuous electricity supply because it's a remote area, and due to long transmission line, there is any interruption, there is any fault, it's cause the interruption of the power supply and need some another source to power. So by combining wind or solar or grid, if your grid fail, you can get power either of wind or either of grid. Or if these two are both satisfactory, we will get power from these two source by synchronizing. So how you can easily synchronize in the MATLAB? That points we will cover. And what is the third one? Another major issue with the fossil fuel is pollution. Pollution is a very basic problem because if you use these types of source, it will cause gases like CO2 and all the gases, and it will definitely affect your environment. So it's caused the greenhouse effect, okay, and climate change situation. Okay, so this is a basic about the problem definition of this project, and by using this method, you can mitigate, slightly mitigate, I can say, the these problems, or you can give your contribution to mitigate these problems. So now we are going to further and understood what is the actually cover in this project. So this is the thing that is covered in this project in this simulation. So what is in the introduction? What is the first point in the introduction? That is the logic behind this project is to integrate a multiple sources. Why multiple sources? Because we have considered the three different sources. That's why I have used a multiple source. Okay. And what is the second point? You are connecting solar, wind, and grid are interconnected and supplying electricity to your household load. I have considered 1.5 kilowatt as a household load, that is a constant load. And normally, a small house has a 1.5 kilowatt load, nearly about a 1.5 kilowatt. So that's why I have considered 1.5 kilowatt. We will understand, or we will see the simulation later on this video. And what is the third point? Third point is with the help of solar energy, or you can consider solar radiation, and a wind speed intensity, electricity can be generated. But energy is not a fix, it's very continuously depends on weather condition and the wind speed. because if the cloudy weather is there, you cannot generate a satisfactory voltage by solar energy. And if wind speed is very low, same you cannot generate a proper voltage. And even though wind speed is very high, to protect your turbine and to protect your generating system, you need to isolate the wind speed. So these conditions are also affecting. So what should we do during this condition? If you are getting satisfactory voltage, then that is okay. You can use the solar or wind. But when this adverse effect happen, what will you do? So you need a some logical controller to isolate during this abnormal condition. So to get rid proper voltage and frequency at load side, here I have developed a logical controller in the MATLAB Simulink. I have developed a logical controller which help to switch different sources according to availability. So if you consider initial stage, solar and wind both are combined and synchronously giving the supply to the load. And what happened? What happened? Suddenly wind speed reduce. So you need to isolate wind turbine. So once you isolate wind turbine, again only solar will take a load. Total load will be taken by only solar and wind is isolated. Now again consider if cloudy weathers are there and cloud are spread over the solar. So what happens? Solar radiation is reduced. Solar radiation is reduced. Solar generation is reduced. So at this condition, your solar will be isolated and totally load shifted on grid side. So this is actually happen. We will see all the logic. So what is the third point? Again, third point is same. It means that in the daytime, if solar energy is sufficient, then total load will be taken by the solar energy. So solar energy will be taken the whole day. With the same simulation or with the same situation, if the sufficient wind speed is there, then solar and wind both combine and to tackle the load. It means solar and wind both are combined and tackle the whole the load. Okay, contradictory in the night time. What happened in the night time? Only wind is available. In the night time, solar is not available, obviously not available. And only wind is available. And if it is sufficient, then wind would be tackle the total load. Only wind will be tackle the total load. Solar is not there. At the final stage, if no any renewable sources is available, so if any no any renewable source, if it is not, if solar is not properly available, if wind is not properly available, then and there grid would be taken the total. So grid is our secondary part. We are mainly focusing on solar and wind. We are mainly focusing on the renewable energy source. If your renewable energy is sufficient, then you need to supply your load on these two. If these two isolate, if in adverse condition, because in very adverse condition, these two are isolated, and even though these two are isolated, you need some supply source because you cannot switch off your load to get proper power system or to get proper supply voltage. You finally switch to the grid. So this is actually logic. This logics will be developed. I have developed in my simulation, and I will show all the things, all these scenarios in the simulation part in the further. So now we are going to the advantages of the multiple sources. So what is the advantage? The basic advantage is reduce the electricity bill. It's a standard. What is the second one? Renewable energy is a free of cost, so no need to worry about it. Renewable is all, solar is also free of cost, wind is also free of cost. Just only need is initial investment is required, and its running cost is very negligible. There is no running cost in wind. What you need to do just maintain your turbine and generator generation. Actually, your alternator, or you can consider DC generator if you use it. So you need to check after some periodically, and in solar there you need to just clean your solar panel in a once in a month. So this is the enough. There is no any major running cost. And why these things are important in the industrial point of view? Zero emission, zero carbon emission. There is no any emission if you use a solar, or if you use a wind. If you use a solar or if you use a wind. And environment friendly, obviously it's environment friendly, and promoting the green energy concept. Green energy concept means you have to get supply from the renewable energy sources. And what is a carbon footprint concept? This is a major concept actually. Industrial now using carbon footprints. It means if you are owner of industrial, and if you generate, or if you are making some component, like just consider if you made an MCB. if you made a MCB, then for a 1 MCB, how much amount of carbon to make a 1 MCB, how much amount of carbon you are emitting in the atmosphere, you need to calculate it, and you need to reduce as much as possible. So this is a carbon footprint concept, and it is a very trending in industrial at right now. So this is a block diagram, and similar we have considered this in the simulation part. What we have considered, wind generation and the solar generation both generate a DC supply. So the DC supply is then inverted using inverter, and this is DC, and then inverter invert the DC supply to the AC supply. And grid is also 24/7 available. And actually depend on these renewable energy sources, we are switching over different sources, and if both are isolated, if both are not available, then grid will supply a total load to your residential load. This is a residential load, is a 1.5 kilo. So this is a basic or similar what I have developed in my MATLAB simulation, and I have considered a different scenario. So before explaining this scenario, I want to show you simulation first. So we are going to the simulation part. Okay, okay. So this is this total simulation. Just consider it's a very simple simulation. There is no any hectic. So this is our grid. Grid is continuously supplying power. This is a grid, and it's continuously supplying. This is some measuring component, and at finally you are connecting. This is the main breaker of your grid, that is connecting your household load. Okay. Similarly, this one is your solar generation. It's a solar panel. You are generating specifically voltage, and I have applied some toggle switches like daytime, cloudy weather, and nighttime. The different sources of supply. So in uh, daytime you are getting proper radiation, so you are generating proper output voltage at this point. And similarly, if the atmosphere is not properly, or cloudy atmosphere or cloudy weather, then your solar radiation is reduced and you are getting some less voltage. We will consider, or we will see all this all the things in simulation very crystal clear way. And this is night time, so there is no any generation. So this is the our solar that is generating some power. By generating power, you are charging your battery. If your battery is satisfactory charge, like I have considered 30% minimum charge. If so whenever your supply is available, first it will charge the battery, and after a 30% minimum charge, it will finally switching on this inverter part. This is the inverter, SPWM inverter, and it's a sine PWM inverter that finally generate a specific satisfactory sine wave. And this is a measuring component. This is the final breaker. If this breaker is closed, you are getting power to your household load. This is a 1.5 kilowatt household load. Okay, to your solar. Okay, this is a solar part. And what is the wind part? I am just explaining the basic overview of my simulation. We will check simulation by running after when we are actually doing the scenarios. This is wind generation. Okay, there is a different normal wind condition, low wind condition, over wind condition. Just you need to toggle this switch. If you toggle normal wind speed, over wind speed, then you are generating some supply sources by supplying the output to your DC machine, DC generator. You are getting some satisfactory voltage. If you are getting satisfactory voltage, then your breaker will be closed. These are some breakers. These are breakers, and breaker will be closed. And again, these outputs are going to charge your battery also. And parallelly, these loads also. This is again an inverter part, and again it is connected to your finally breaker. Not a breaker, it's a household load, and breaker is here for the wind. Your this one. This is your breaker for your wind. uh, this is your breaker for your solar, and this is your breaker for your grid. So according to scenario, different scenario, and according to logics that I have developed here at different parts, your breaker will be on and off. So now this, I think now you understood the basic scenario and basic simulation what I have covered. I have just considered three different sources. One is grid, second one is a solar, and third one is the wind. So what are different scenarios of sources? So scenario number one, only grid power is available. Grid power available and supply the total load. Meanwhile, solar and wind are not. So this is the first scenario. We will make this scenario in also. What is the second scenario? Only solar power is available. Only solar power is available, and your wind and grid is not available. What is the third scenario? Only wind power available. So here we are segregated three different sources: only wind, only grid, only solar, and only wind. So at this time, only wind available. So solar and grid is not available. What is the fourth scenario? Solar plus wind, you are synchronizing by simple method. I will explain in simulation. Solar and wind power sources are available, and at that time, if these satisfactories are available, these two are satisfactory available, grid is isolated. This is the fourth scenario. And what is the fifth scenario? Solar to wind or wind to solar power changeover on a different condition. So when solar fail to tackle the load, when solar fail to tackle the load, wind will be single-handed and tackle the load. So what is the before scenario? Before wind and solar both working condition, okay, both are synchronizing, workingly perfect. But what happened? There is some abnormality happen and solar is isolated. Then only wind, a single wind, a singly handle or tackle the load. And whenever both fail, even solar is also fail, wind is also fail. Then and then your grid come in picture and tackle the boulder load, or vice versa by now again if solar is generating proper output, then grid will be isolated and again switch to the solar. And if your solar is working and wind is also properly available, then solar plus wind both are synchronized. Okay, so this is the circuit diagram that I have already covered. The grid power, solar power and wind power. Okay, and I have just mm, highlighted the grid power sources because we are considering scenario 1 in which only grid is available and supplying your source. So 1.5 kilowatt household load getting supply from the grid. So this is your grid and it is generating household load. So this is the waveform that you are getting when you are supply from the grid. So now we will check how you are getting this type of waveform. So meanwhile solar and wind is isolated. Okay, okay. So to simulate this one, you don't have a wind, so I have switch off all the switches. You don't have a solar also. Switch off all the circuit, and just your grid is available. And we will check this breaker. This breaker is one or not. By by displaying, you can see if it is one, then this breaker is one. And for this simulation, you need to discharge your battery. So it's a 29 percentage. Okay, so already discharged. Minimum value is a 30. Okay, so whenever I simulate it, this will take some time to simulate. So just wait. We cannot do anything. It's time to take. Okay, so you can see here. Yes, your breaker is off condition. This is your solar breaker. It's in the off condition. This is your grid breaker. It's on the on condition, and this is your wind breaker. Wind break, it is also in the off condition. So it means that only grid is available and grid is supplying your total power from the grid side. So you can see here the waveform. It's a very clear. Waveforms are very sinusoidal because it's directly from the source. Very clear waveform that you are getting. Okay, sine wave and RYB and I have. And if you want to proper RYB, you can get here also like RYB. You can see it's a very it's a discrete waveform, that's why you are getting it, but it's a sine wave. Okay, so I am stopping it. So I think I have covered the scenario 1 and you are getting type of waveform. Okay, so what is the second scenario? Second scenario is the solar power source circuit. So in the second scenario, you are supplying your load totally depends on solar. So here the solar I have already explained this this circuit. I have just highlighted the solar circuit, and this is solar power, solar energy, solar cell that charge your battery. After battery specifically charge like a 30%, it will allow this inverter to turn on and supply the total load through these breakers. Okay, the 1.5 kilowatt load, that is our this one at output side, household load. Okay, what is yes, this is the different condition of the radiations according to the situation. You can use any toggle switch according to your requirement. If it is a daytime, it is daytime. If daytime means a satisfactory supply, satisfactory voltage generated, and satisfactory solar radiation is there. So 950 is a satisfactory generation, and you have applied the solar to your solar panel. And like daytime, cloudy weather, and nighttime, three different conditions are there. A battery is charged through your solar energy. A battery charged specifically to solar energy. I have used a battery because to reduce the start stop or even to reduce the spiking. Battery use first battery will charge and then it supply the load, so it will protect our load from any voltage imbalance. And the last one is in normal situation, daytime toggle switch is in the on position. So normal situation, this is in the on condition. And this is the inverter part. Okay, this one is the inverter part, three phase inverter, a DC to three phase AC supply. Okay. And yes, this scenario now we will check what is the first condition: solar toggle switch in the daytime and wind speed. There is no wind is available. That's why all toggle switch are off condition. And here battery is 29.95%. Why 29.95%? Because in initial stage you want to check that your solar the grid to solar changeover. You need to check grid to solar changeover. That's why I have used the 29.95%. So just simulate a similar value in this simulation, and your your daytime is available. Okay, and your wind is not available. So all the switch are in the off condition, and your battery is a 29.95%. So first why 29.95? Because whenever your solar is available, this battery will get charged first and then switch over the solar. So in between 29 to 95 to 30 percentage to charge 29.95 to 30 percentage. Meanwhile, your grid supply will remain on. So just check here, and like 1 minute. Okay. Uh, Note this breaker is one. Check this one, and just check these two one. So whenever I start the simulation, first of all, this will remain 0 and this will remain 1. After some time, whenever the battery are satisfactory charged, this will remain on, this will become on, and this will become off. Okay, so this is one, this is off. So it's clearly mean that you are changing from grid to solar whenever your solar supply, solar radiation is properly available. Or even you can consider there is some voltage spike. So there is a this is our voltage spikes, and that is happen because you are using a inverter. So if you are averaging it, you are getting proper signal. So this you can clearly note that you are changed from grid to solar, and there is no any major spike, just like small spike. And this is the waveform, that's why this is a PWM techniques, that's why we are getting this type of waveform. But if you are averaging it, you are getting nearly sine wave. Okay, so this is how you are getting or you are getting changeover from grid to solar. So what is the third scenario? Again, third scenario, you are only getting power through wind power or wind supply. So this is the highlighted part. This is the wind turbine, and these are some toggle switches that used to create a different situation. And again, these are some breakers to switching on and off, and these are your inverter part. Okay, so using toggle switch in a normal condition, low and high wind, three different situations can be created. So normal wind, low wind, and high wind. And DC generator is used to generate a DC, and by inverter we are converting it to three phase supply. Okay, so same scenario we are used here also. For a solar, all the switch are off condition, it means solar is not there, and wind is in the normal position, and battery is 29.90% charge. So we are creating this situation. So first of all, what is it? I need to switching on, switch off the all the solar simulation, because we are not okay. Okay, it's already in the running condition. So I am just switching off the solar because I don't want solar and I want a wind. So I want a wind. That's why I have considered a normal wind. Okay, so it's a normal wind switch. So now there is no any solar. but there is a wind. There is a wind. And again, your battery is a 29.90% charge. And first of all, your grid will be supplied. So here again, battery takes some time to charge from 29.95 to 30%, and meanwhile your grid supply is on. So just focus on this breaker, this one. This is your main grid breaker, and this one. This is your actual breaker of the. So I am just okay. This one and this one. So I am starting the simulation, and you can here see that your normal wind speed is available. Okay, so I am starting. You need to focus on these two breakers. Upper one is grid side and lower one is your wind. So I am starting the simulation, and just take wind takes some time to generate a voltage. So meanwhile your grid breaker is on condition, and whenever your satisfactory voltage is generated and your battery gets charged, and whenever your battery gets charged, uh, okay, okay. Your battery is charging. Then it's a one and it's a zero. So you have changed from the grid to wind. So this is how from grid to wind changeover happen, and you can easily detect in this waveform. Again, you can easily detect in waveform. It's changed from the grid to wind, and you cannot hear your this breaker is on one condition, but you can see here your solar power is not available. Okay, so it means you are totally supplied from the wind. Okay, so for the sake of understanding, I have used two different breaker from solar and wind, and it is already connected to your battery. So if you don't want to use this breaker, you can use this breaker also to switch on and off to your load, or to switch on and switch off your renewable sources for specifically your load. So I have used this breaker to just get proper illustration of how simulation is work, and I have used two different inverter, but by using these inverters only, you need to just switching on and off this condition, and here already logics are developed. So you can consider only these parts also. No need to create a whole the module, but for sake of better understanding, I have the two different. So now we are switch back to our fourth condition, and what is it? Solar plus wind power supply. So it means wind and solar both are combined and giving to the supply. So what is the condition? Daytime and normal wind speed and battery is 50% charge. So now we are back to our simulation, and it's a daytime. Battery is 50% charge. Okay, and your solar wind speed is normal. Okay, so whenever I start the simulation, you can see here the voltage is increased, and after specific time, after a properly voltage is increased, you are getting a high voltage, or high means you are getting a 1 here to start to turn on this breaker. So whenever your voltage is greater than 400, then and then your breaker is on, and if it is over, then it's off. So this is how you are properly on off your breaker. So at this condition, your both solar and wind are synchronized, and power to your load. Both breakers are one, and both voltages are properly. Here I have used a synchronizer, synchronized by this simple electronics circuitry. This electronics inverters in both the supply source cause and better synchronization, because in synchronization, what is the requirement? Your voltage level should be same, your frequency should be same. That is already same because I have used the same inverter, and there is no any back current, your back current, or no any reverse current is not possible due to these diodes, due to these inverters. Okay, so it is a condition in which you are getting a power, from both solar and wind. Okay, so at this position your voltage spike is there because after some specific time, because wind takes some time to generate a voltage. Solar easily generate your voltage at the same time, but wind takes some time because turbines take some time to rotate to a specific time, it will take a specific time to rotate to get some speed, and after that specific time is overlap, you are getting a solar, you are getting a wind power, and at this position there's some spike. Okay, and if I highlighted, okay, it's output of your inverter. Okay, so if consider like these two are working, and if an a over wind speed scenario is happening, over wind speed is happen, so what happen, you can see here your voltage is increased, and if your voltage is increased, your breaker is turn off, your both breaker are turn off. Okay, and if your both breaker are turn off, your main breaker is also off, and these are all the current are zero. So at this condition, only wind is only a solar is supplying your load. Wind is not in the picture, wind is isolated. Yes, here at this point wind is isolated, there is some spike. Okay, you cannot the spike. Okay, so now we are checking the scenario 5. So what is the scenario 5? Solar to wind power changeover. So what is the before condition? Before solar and wind both are in proper condition, in working condition, and after some specific time what happened, cloudy weather are happen, and your solar will be isolated. So you can create this model, this actual running time model also. So just consider in previously it is working properly. Okay, it's a normal wind speed. Okay, so I have just set according to it, and your battery is also 50% charge. Okay, so I am starting the simulation. So everything is okay, solar and wind both are synchronized and giving supply to your load specifically. Then what happens, suddenly weather change, and what is caused, weather change caused the cloudy atmosphere, and cloudy atmosphere cause your generation in your reduce your generation. So just I am switching off. So okay, and cloudy atmosphere, so your voltage is generator voltage is reduced, and due to reduction in your voltage, your breaker is off. Your breaker is off. Your solar generation breaker is off. So at this condition, your your wind is available. Your wind is properly available, and its breaker is also closed. You can see here all the breaker are closed. One, and it is powered. Your battery also. Your battery is charging. You can say it is charging even though your solar is off. Your battery is charging, and it is charged on wind, and it is supplied to your load also. Okay, yes, you can see that there is some spike because your solar is isolated. So this is the different spike, and these spikes depend on how you are changed over here. So if you switch off the breaker first and then switch on this cloudy, then you are getting spike in lower side, actually here, actual hour in the simulation. Here you can see it's a lower side and upper side. But if you switch on directly this cloudy weather, and after switch on, if you switch off this breaker, then you are getting this type of spike upper side. So that totally depend on how you are switching off. That is not a matter, but our main concern is how it's changed over, how it's changed over. So it's a very easily you can detect it's totally changed over, it's a totally shifted on your wind. And here you can see very very slide, very slow variation, and it's a very short time, and it's a very stable after a particular time. Okay, you are getting a very proper waveform, proper voltage. Okay, and this is how this scenario is completed, and your battery is also getting charged. You can see 50.60 to 63, it is a continuously charging, and it is charged through your wind supply. Or what is the scenario 6? Okay, oh, it's a scenario 5 again. Before it is a daytime normal wind speed. Now what happened? Over wind speed scenario happen. Over or lower, any of these will happen. So at this time your wind is isolated and only solar is available. So we will check this one also. So to check this scenario, we need to switch back to our simulation and check. Okay, you need a normal daytime. Okay, now cloudy weather. You don't want a cloudy weather. You need a natural selection. Yeah, okay. Normal wind speed and solar, normal radiation of the sun. So after some time, the system will stable. Your voltage is increased because wind does not start instantaneously. It takes some time to start, and once it is start, you can get your all the breakers are on. Now what happened? Everything is clear. Wind is also okay. Solar is also okay. You are getting a proper output voltage. Then what happened? Suddenly bad weather condition happened, and it caused a very high wind speed. So now if I switch off and switch on this, so very high wind speed cause very high voltage, and very high voltage cause the isolation of your breaker. And once your voltage is very high, you have isolated it. It's, you can see every breaker is are zeros, and your main breaker is also zero, and it is a totally switched over to your solar solar. And even you can see battery is also getting charged. And you can see here, because solar is available, that's why your battery is charging. And okay, your some variation some variation. And if you just isolate your turbine, I have used this signal also. So if your breaker is it means that you need to just isolate on overwind speed by this signaling switch. So what you need to do here, you need to just it's increase or change this to greater than or equal to. So if I change over here, then okay, this is one, and there is no wind speed here, so there is no voltage generation here. So according to this way, you can create a logic to isolate the input over high wind speed. This is high wind speed. Okay, so there is no any voltage here. Beforely there was some voltage, and it's isolated according to this logic. But if you want to create a logic at initial stage, or just initially, you need to isolate your turbine. Just you need to change this value. But you can use this one also and previous one also. Both logics are working in condition. That's totally depend on how you are using it. Okay. So this is a fifth scenario in which initial stage solar and wind both are in working condition, but after some time, let's consider the cloudy weather condition happen, and it cause a very high wind speed and cloudy atmosphere, and that cause the solar and wind to isolate and change it over to our grid once again. So just creating the situation according to mention here, and check the simulation, and then we will change the real time. So okay, it's a daytime, so solar is okay, and it's a wind time, normal wind speed, and your battery is also 30.10% charge. I have considered very nearer percentage because of to check after discharging of battery it is change over to a grid or not. Okay, so what happened? Your voltage is properly, so it's everything is on. And what happened? Over wind speed is here happen. Over wind speed happen. So over wind speed cause reduction in your supply voltage, and mm, that cause isolation of the wind. Okay. Now what happened again? After some time, your uh, solar is also isolated. So at this condition, you can see here the battery is getting discharged, and you don't have even a wind source and don't have even a grid source. Everything is in the off condition. You don't have a wind, you don't have a solar. So what is remaining? You have just a wind grid. So you can see here it's a finally switch over to grid. Yes, there is some voltage variation due to this battery is discharged. You can see it's a change over to grid. So once again we are considering checking this simulation properly. Okay, so initial stage, what was the condition? Condition is it's a daytime, and your over wind speed. is it normal wind speed condition. Now I am starting the simulation. Everything is perfect. So now we are consider low wind speed instead of over wind speed and check what happens. Your voltage is perfect and your solar, so your battery is also charging. It's a charging. You can see battery is charging. So now what happens? Suddenly low wind speed scenario is created. So I am consider low wind speed. Okay. So your voltage is drastically reduced. You can see here your voltage is continuously reduced due to low wind speed, and so that your wind is isolated, all the breakers are off condition, and at the same time the solar is there. That's why your battery is charging. Now if consider the solar is also isolated, there is no there is no solar, there is no wind. That's why your battery is continuously discharged. Due to discharging your battery, your breaker is turning off, and whenever this breaker is turned on and finally switch over to grid. So for both condition it is working perfectly. uh, this low voltage happen due to battery. You are finally changed to the battery, so there is some time for a 1 to 2 second there is slight voltage drop, and then finally it is perfect due to continuously changeover, and there is a very low voltage. This battery is again continuously discharging due to internal circuitry and this component. Okay, so this is how you are finally change over to grid whenever any abnormalities occur for both over wind speed condition as well as low wind speed condition. So this is how the simulation is work. I think I have covered all the specifically all the scenarios, all the 5 scenarios we have completed very crystal clear. So now we are going further. What is the further? Further is a saving in electricity bill, and that is also I have calculated here. So it is a fixed load, it is 1.5 kilowatt fixed, and if you consider the 24 hours power consumption from grid, so it's a 1.5 kilowatt 24 hours, and uh, let's consider hourly charge 9 kilowatt, 9 rupees per unit is charged. So your per day bill is 324 rupees for 1.5 kilowatt load, and that is a constant load. And if you are using it totally 30 days, and consider 30 days, and your monthly bill for this specific load that is continuously running, it's a 9720. 10,000 rupees is your monthly bill. But if you use a solar, if you use a solar, and if you consider 8 hours solar power is available, so 24 minus 8, it's a 16 hour. So you need just a 16 hour remaining time grid supply. So what is the monthly bill? 6480. 6,480 rupees your monthly bill if for 30 days continuously 8 hours solar power is available. Just a consideration. If there is no solar power, then your bill is 9720. If just for 8 hours solar power is available, then your bill is drastically reduced to 3000. Now just consider solar and wind. Both are available for 18 hours per day. So remaining 6 hours we want to use a grid supply. So just 6 hours. So what is the per day bill? It's just 81 rupees, because 18 hour remaining 18 hour wind and solar are available, and we are getting some supply from that. So finally your electricity bill is reduced from 2430, it's a nearly 2500 rupees, 2500 rupees. So you can see here how the changes look like. You can reduce your electricity bill from 10,000 to 2500. So you are getting your reducing your electricity bill to 75 percentage. Only 25 percentage of your total bill you can you need to pay. Okay, you are reduce your electricity bill by 75% by just implementing this concept, and by just implementing this solar and wind parallelly to your grid. So this thing is mentioned here, saving in electricity bill. Okay, sorry. Mm, This all scenario we have considered. This is the first one. So if there is no any renewable energy for 1.5 kilowatt, 9720 electricity monthly bill. 8 hour power solar power is available, then 6480. And if 18 hours of wind and solar both are available, so this is your electricity bill. These are the reference paper from which I have uh, got some knowledge of the simulation. And thanks for watching this video. If you have any query, just comment it. I will definitely reply. You will get this simulation file, this PPT, report of this project, all the research paper that I have mentioned, all the things what I have. I will share all the things. You can connect with me through my email ID that is given in the description box. And if you have any if you want that I work with you for your MATLAB project, you can connect with me through my email ID that is given in the description box. You will get this all the project in just minimum price, and it is mentioned in the description box. You can connect with me through my email ID that is given in the description. Again, thanks for watching this video. And if you have still any query, just comment it. I will definitely reply. And don't forget to like and subscribe my channel. Thanks for watching this video.